Good morning, everyone. My name is Justin Sears, Product Marketing Manager at Hortonworks. It's my pleasure to host our 7-webinar series entitled Discover HDP 2.1, covering all the new capabilities for Enterprise Hadoop delivered in Hortonworks Data Platform version 2.1. Today's interactive SQL query in Hadoop with Apache Hive is the second webinar in the series. If you missed last week's webinar, New Features for Security in Apache Knox, you can find the recording and Q&A on our blog. I'll be your host today, and I'm joined by 2 Apache Hive experts. Carter Shanklin is a Director of Product Management at Hortonworks. He's responsible for Apache Hive as well as HBase, Flume, Scoop, and Uzi in Hortonworks Data Platform. Owen O'Malley is one of the original architects of Hadoop. He is a Hortonworks co-founder and now a committer to Hive and other Apache projects. Here's today's agenda. We'll begin with a discussion of how Hive 13 enables interactive query over petabytes of data using familiar SQL semantics. Then we'll give a brief demo, and we'll finish with time for Q&A. We've got 30 minutes, so we're going to move quickly. All attendee phone lines have been muted. If you have questions during the presentation, please send them to Owen O'Malley in WebEx chat. We will take time to answer those at the end of the call. If we do not have time to answer all of the questions, we'll include a full Q&A in an upcoming blog post about this call. So let me set the stage for Carter and Owen. This is a modern data architecture to store and process data from a wide variety of sources. Data comes in structured columnar formats and also newer, less structured formats like those found in human-generated content like Word documents or videos, and also in weblogs and clickstreams, social content like tweets, and machine sensor and geolocation data. Those data sources are shown down here at the bottom. Apache Hadoop works well in combination with familiar data repositories like RDBMS, EDW, and MPP to store and process a full spectrum of data. You see that here in the middle. That data is then available for a variety of data access applications and BI tools to complete many different data workloads: batch processing, interactive query, stream analysis, NoSQL, search, and others. Through our experience with more than 100 enterprise customers running HDP, we know that enterprises need 3 additional capabilities to be integrated with data management and data access that you see in the middle of this diagram. They need data governance and integration, they need to secure their Hadoop cluster, and they need tools for cluster operations. In today's webinar, we will focus on one of the principal tools for data access in Hadoop, Apache Hive for interactive SQL query. We will cover other components of Enterprise Hadoop in additional webinars over the next 6 weeks, and a recording of last week's security webinar is already available on our blog. So now I'll turn it over to Carter Shanklin. He and Owen will discuss HDP 2.1's capabilities for interactive SQL query. And please remember to send Owen O'Malley any questions in chat. We'll get to those towards the end of the presentation. So now I'll turn it over to you, Carter.
So thanks everybody for joining us today. As Justin mentioned, I'm Carter Shanklin, Director of Product Management here at Hortonworks, and today I'm going to talk about the Stinger initiative, and which was really an initiative to improve Hive's performance by 100x. I'll talk about that. I'll talk about HDP 2.1, where we've introduced the phase 3, the completed Stinger initiative, into HDP 2.1, and finally I'll give a demo of interactive SQL query on top of Hive. So first, a little bit of background for some of you who may not be completely familiar with Hive. Hive is a SQL engine for Hadoop designed to process very large amounts of structured and unstructured data. So Hive was originally developed at Facebook back in about the 2006-2007 timeframe, and today Hive powers Facebook's 300 petabyte data warehouse. So Hive is really the most widely used SQL tool in the Hadoop ecosystem. It's supported by all the Hadoop vendors. There's more than 20 BI and analytics tools that support it, and pretty much most of the other ETL and data integration tools that you see integrating with Hadoop use Hive as the integration layer. Originally, Hive was really just designed to process large amounts of data in a batch way. So large amounts of data and latency was acceptable. So anyway, so Hive originally was really around batch, but as more people have adopted Hadoop, people realize that they have different needs. They need SQL analytics over different kinds of workloads. Some of it may be reporting, or maybe data mining, or even down to interactive analytics. So it became clear that Hive needed to advance and evolve to be faster and to be more interactive, so people could address all these needs with SQL tools natively within Hadoop. So that's why the Stinger Initiative was launched. Stinger Initiative was really an open roadmap developed 100% in open source to improve Hive's performance 100x and introduce interactive query to Hadoop. So when you look at what Stinger brings and how Stinger delivers the 100x faster performance, it really kind of breaks down into three areas. First is really changing Hive to make use of Apache Tez. And Tez is a next generation MapReduce that handles SQL processing a lot better than MapReduce does. Secondly, there's a vectorized query execution engine which takes advantage of modern CPU hardware to process rows in large batches rather than one at a time. And by doing this, you get a 10 or more X improvement just on query execution. Finally, there's ORC file. It's a modern columnar format with very high compression, which helps lead to very efficient I/O. So the combination of these three elements together are really the main driving forces behind the Stinger Initiative. So Hortonworks released HDP 2.1 in April of 2014, and that includes Hive 13, which basically represents phase 3 of the Stinger Initiative. And there are really a lot of things in HDP 2.1 that improve speed. Most importantly, really, is the introduction of Hive on Tez. I'll be showing a demo using Hive on Tez and interactive query in just a little bit. But some additional things that speak to speed, the vectorized query execution engine, as I mentioned, and also a cost-based optimizer was introduced in 2.1. So all of these features speak really not just to better speed, but also better scale that you get out of Hive. So another thing that has been evolving in the Hive ecosystem is really the SQL semantics that Hive supports. And with HDP 2.1 and Hive 13, there was an introduction of more than 10 new SQL features. That includes things like correlated subqueries, common table expressions, new data types, and a lot of other things. So if you take a look at this table, this table tries to paint a picture really of the evolution of SQL semantics in Hive and SQL support in Hive. And what you see really is if you look at the past 18 months or so, the SQL support in Hive has really grown very quickly. And, if you look at Hive 13, you get actually a very comprehensive set of SQL semantics. At this point, Hive supports more SQL features than any other open source SQL engine for Hadoop. And you also see, if you kind of look at the roadmap and going forward, new features like insert, update, and delete. You see basically that Hive's SQL support will continue to grow and expand. And I'm going to show off a few of these features when we get to the demo in a moment. So before we get to the demo, a few other new features I'll mention about HDP 2.1. One feature that gets our users really excited is SQL standard authorization. And this is a feature that allows you to do row-level or column-level security using SQL standard commands like grant and revoke. So if you have an existing SQL process or SQL security needs, you can pretty easily translate those over to Hive. So a lot of users very excited about that. And we've also introduced a Hive tuning tool in Apache Hive, which I'll be showing off later. It makes Hive queries a lot easier to diagnose and understand. So with that, I'm going to get to the demo. I'm going to show off a couple of things in the demo. First of all, I'm going to show some of the new, first of all, most important, I'm going to show the interactive query capabilities of Hive. I'm going to talk about some of the new features that we've introduced in Hive 13. And finally, I'm going to show the job analyzer, the Hive job viewer, that's part of Apache Ambari. Those of you who may not know about Ambari, Apache Ambari is a 100% open source management and monitoring console for Hadoop, and I'll show you how it introduces some nice Hive diagnostic features in a bit. So for this demo, I'm going to use a data set called the FoodMart data set. This is FoodMart is part of the Mondrian package. So if you want to grab this stuff and play along at home, you can certainly do that. The Mondrian data set out of the box is a bit small, so I took it and I sort of upsized it. I replicated all the fact data 275 times, so it's about a 10 gig data set that I'm going to be running on my laptop here in an HDP 2.1 sandbox. So it's a single node 4 gig sandbox, and I'm going to be crunching on this data. So there's a bunch of tables, but the queries I'm going to use, they hit one large fact table, the sales fact 1997, and I'm going to take advantage of a few of the dimension tables that you see here. So FoodMart simulates a grocery store chain, and as a scenario here, let's say we're trying to do some targeted marketing. And let me switch over to my demo environment here. Can somebody confirm you're seeing my console windows? Okay, great. So what I got here, I've got a couple of consoles into an HDP sandbox running locally on my laptop here. And on the right-hand side, I just have the queries. And on the left-hand side, I have a Hive console where I'm going to be running these queries. So I'll show you guys. I have 3 queries here, demo query 1, 2, and 3. If we take a look at demo query 1, that's the text of that. So we've decided we're going to do some targeted marketing, and as part of trying to figure out who we're going to send advertisements to, we decided we want to try to target people with a good amount of disposable income. So we decided we're going to try to find people who have more than 3 cars. Basically, if you kind of look in the SQL here, very simple, very familiar SQL syntax. We're going to try to target people with more than 3 cars and no children at home living in California. So we kind of presume these guys have plenty of money to spend. So in order to do that, I'm just going to sit here in my Hive console, and I'm just going to source in that query to execute it. So this launches a job, and if you kind of look at this stuff here, the interpretation, let me scroll back up a little bit if I can. Hopefully you guys are seeing this. But basically, the TES job, one of the key things about why TES is better for SQL processing is it'll run queries like this in a single job rather than trying to schedule multiple jobs together. So you kind of see all the different maps and reduces happen, and you kind of also get a hint that Hive breaks down a lot of the data processing. It kind of does a divide and conquer. In this map 2 wave, you kind of see that it splits the data set into 7 different inputs and crunches on those separately. So basically what I've asked Hive to do is pull out the customer IDs. Hive pulls out those various different customer IDs. At this point, I would probably feed these into a different tool, maybe like a marketing automation tool or something like that. So one thing I'll kind of point out here is within Hive 13, Hive on TES, the time taken was 6.3 seconds or so. If you think back to sort of, if there's any Hive veterans in the audience, you'll notice this is quite a bit faster than what Hive historically was able to do. If you think of really old versions of Hive, the same query would have taken several minutes to execute. So let's move on to a second query that actually shows off some of the new query capabilities. So let's say that instead of targeting people specifically in California, I want to do more of a regional targeting. And let's say that I decide that I really want to start doing some targeted marketing in the Northwest region. Now, how do I sort of figure out what states are in the Northwest region? So this is a good case when you want to introduce a subquery in the in clause, as I've sort of done here at the end of the query. So basically what I'm doing is I'm pulling in another dimension table called region, and this dimension table will basically decide what states are parts of various different regions. And the reason this is good is because arbitrary designations like region can change at any time. So maybe one day you decide Montana is in the Northwest, and one day you decide it's in the Central or something like that. Who knows? These kind of arbitrary designations can change, and you don't want to have to rewrite your queries when you do that. So that's why it's good to have these kind of subqueries. And at this point, this is a new feature in Hive 13. Hive is now able to basically process this query as it is. So let me just run that guy as it is. What you'll see here, if you kind of compare that to the prior query, is there's an extra map step. That's basically computing the subquery, and then it's joining that to the other result set. So we've this is kind of a demonstration of that subquery capability, and again we have nice interactive response times. So final thing I'm going to do, I think time is kind of winding down, so I want to move quickly. Query number 3. So in this last query I'm going to do, I am going to show another new SQL feature that we've introduced called not exists. So basically, we've introduced support for a couple of styles of correlated subquery, exists and not exists. And this one, in this scenario, what I'm going to try to figure out is whether we're going to try to identify people who only shop in our store in December, so we don't see them any other time of the year. So basically, in this query, what I'm looking at is I'm going to get basically all of the people who have made a purchase in December, and then I'm going to subtract out people that we see other times of the year. So you see, at this point, we say the month is December, and at this point, we look for people who have bought items in a month other than December, and we subtract those out. So basically, we're sort of trying to find anybody who maybe is only like a Christmas-only shopper or something like that. So maybe we want to see those people at other times of the year. So again, we were able to run this query syntax just as it is. That's a new feature in Hive 13, and a nice, very powerful and intuitive way to answer a question like this. And we see a good, sort of interactive response time on that guy as well. So a little bit behind where I want it to be. I'm going to kind of jump over into another little demo here. I want to show the job viewer. We have within Embari, this is the management tool just running on my sandbox here. I'm going to flip over. This is a new tab called Jobs here, and basically within the Jobs tab, I'm able to look at all of the various Hive queries that have been running. So this allows me to take a look at various queries, and I can drill into them to kind of get a look. What I see here is essentially a DAG that, a graph really of the various different steps within that query, and I can kind of drill into that to figure out various pieces of information. I see, bits of the explain plan. I'm able to drill into that in terms of number of rows processed. I'm able to look at the amount of data that flows through. I'm also able to look at things like spilled records, which are kind of a common indication of performance problems. So it's a nice way to sort of troubleshoot and diagnose a Hive job. So this is new in Embari. I think I saw a question actually that came up, which is what version of Embari is this? Let me actually see if I can figure that out. I think it is 151.
Just save it all.
Okay, so I think it is 151. Whoever asked that question, but so that's kind of my demo, and I think I'm done here. So let's try to move on to questions. Maybe we can get a few questions answered in time here. And how do we want to handle this, Owen?
Okay. So
go for it.
The first question was from Ravi V. Are we using the Tez engine for processing these queries? And the answer is absolutely yes.
Yeah. So I mean, one way that you can sort of tell that is basically the output of the query when you run it under Tez is extremely different than under MapReduce. You kind of see a progress report of all the different parts of the query. And the other thing that you'll notice is it runs as one individual job. In the old days, in the MapReduce days, it would have run as 3 or 4 or 5 jobs. So, okay.
So the next question was from Eric Harper. Does Tez leverage in-memory processing?
So does TES, well, I guess I don't need to repeat the question, bad habit of mine. Yes, there are various ways in which we take advantage of memory. Most importantly, in a lot of ways, basically by doing what's called a hash join. There are various things that we do to take advantage of memory. In this case, one of the things that provides a huge speed up is we automatically figure out what tables can be sort of sucked into memory, and then stream the large table through that. If you go back in time, the old versions of Hive didn't used to do that, and that's one of the big reasons why they were so slow. So we do take advantage of memory in a lot of ways.
Let's see. So the next question is from Adam Kawa. Are there plans to integrate Orc with other tools like Crunch, Cascading, Spark, Giraffe without the use of HCatalog?
So yes, Adam, we've got plans on our roadmap, basically to deal with basically have native support for Cascading and Crunch. I know you guys use Crunch. So, hey Adam, how's it going? And so forth. So that is a focus. We've introduced native org file support for Pig, and so there's some additional work to sort of split org file, really decouple that completely from the Hive engine, so that it's very easy to use outside of Hive.
Let's see. Robbie V asked, does Hive use only one reducer?
So does Hive use only one reducer? There I go again. It depends on what you're doing. So Hive will automatically decide how many reducers it thinks it needs. Now there are certain operations where you have to use one reducer only, and there's certain things like if you're doing order buys, a lot of times you have to have one reducer at the end. But Hive will, if you have a lot of data that you're dealing with, Hive will guess how many reducers it needs, and you are able to sort of tune that if you find that's not appropriate for you.
Let's see. So Adam Kawa asked, are org stats used to optimize the number of map tasks? For example, he has a very wide table, but he only reads 2 columns. Will Hive test be able to notice this and will start fewer tasks than needed for a full table scan?
So that's a little out of my depth on that one, I think. I don't know, Owen, if you know more about that.
We're starting to put that stuff in. Most of that will come in the next version of Hive because we're improving the statistics gathering, but the cost-based optimizer, the main thrust of that work is going to come in Hive 14 instead of Hive 13, and it'll use that the stats gather to scale up and scale down the job appropriately.
Okay.
Let's see.
3 minutes.
Actually, Artem Ervit asked again whether this was Ambari 1.15.
1.51. Yeah, I think it is. I don't see a version tag, but I believe this is Ambari 151. So this is the version of Ambari that shipped in April, and I think it's called 151. But if we release 1.60, it's also in 1.60.
All right. We also got asked, when should you not use TES with Hive?
When should you not use TES? There we go again. There are a few Hive features that TES does not support yet. So, for example, the SMB join and the select transform syntax, and there's one other that escapes me. But there are 3 situations where the feature is not yet supported, and you have to revert back to MapReduce mode. So I think I like to sort of look at that. I like to ask the reverse of that question: is when should I use Hive on TES? And the answer to that one is really, if you need an interactive query, you need to use Hive on TES. If you want to get faster processing of queries, Hive on TES, you should try it out. If you have a job that you've been using for many years and you're happy with it, and I think in a lot of cases, if it's not broken, don't fix it. So if you're happy with Hive on MapReduce, which has actually gotten a lot faster as of Hive 12. I would say use Hive on Tez for your most demanding jobs or anytime you need interactive query.
Although absolutely the direction going forward is to replace MapReduce completely with Tez.
Yeah.
Definitely the roadmap is for the MapReduce legacy base to go away and to use Tez for everything.
Okay, one more question.
One more question. The last one's a doozy. Can you compare Hive and Tez with Impala?
You can absolutely compare Hive and Tez with Impala. We see people doing that every day. So I think that if you are doing a comparison like that, the things that we encourage you to compare it on is, take a look at how the systems behave under scale, under a variety of workloads. Don't make sure you're not just hitting 5 gigs of data and you're making your decision based on that. Make sure that you look at it with a large amount of data. The other thing is look at the SQL semantics. Are you able to plug in the tools that you need? Are you able to do the depth of SQL processing that you really need? At this point, Hive has quite a few more SQL features than you'll get from other open source SQL tools for Hadoop. And I think we're out of time.
Yeah, and that takes us out of time. We'd like to thank you for listening, and here's Justin.
And can you show the last slide, Carter?
Can I show the last slide? Yes, let me do that.
Oh, and we'll address the remainder of your questions in a blog post. So if your question didn't get answered this morning, we'll get to it and post it on the blog.
And this is Justin again. I apologize, I have a little technical issue with my machine apparently, but I want to thank Carter and Owen for carrying on and taking the time to share your experience with interactive query and Hive. I also want to thank all of the attendees. Thank you for taking the time today to learn about Hive 13 and HDP 2.1. As Carter and Owen have mentioned, a recording of this will be available in an upcoming blog post, and we will answer any questions that we didn't get to on the call in that blog post. So if you haven't signed up for the remaining 5 Discover HDP 2.1 webinars, you can do that from hortonworks.com/webinars, and that's right here. And next Wednesday, May 21st at 10 a.m. Pacific time, we'll hold the 3rd webinar in this series, Apache Falcon for Data Governance in Hadoop. We hope that you can all join us for that one next week. Thanks again, and this ends today's webinar.